Welcome, viewers. So we have a question here on physics, actually on what? On lights. It says an object of 0.04 meter high is placed in front of and at right angle of the axis of a concave mirror which has radius of curvature 0.15 meter. If a real image 0.12 I is obtained, determine the distance of the object from the mirror. Now let's go this way now. We have solution. Now don't forget that we are giving what the height of what? The height of the object. Okay, an object of 0.04 meter high. That is height of object. Let's use HI for it. 0.04 meter high in front of and at right angle of the axis of concave mirror which has radius of curvature. The radius of curvature is given as 0.15 meter. If a real image of 0.12 meter high, so you have the height of the image 0.12 meter is obtained, determine the distance of the object from the mirror. You have to determine what distance of the distance of what of the object from the mirror, which is u. That means that u is not given. Distance of the image is what is u. That's what I have to find. But we are given the height of the image and height of the object. Also given what radius of curvature. So I'm going to formula for mirror. Formula for mirror is we have 1 over v plus 1 over u equals to 1 over what? F, which is focal length. V represents the distance of what? Of image. V is what? Distance of object. While F is what? F is the focal length. Now, first is that we are giving, we have to find this, but why this is not given? But we're also giving what? Focal length, right? But focal length is not directly given, but we are giving radius of curvature in the question. So from what we have in this thing now, we are giving radius of curvature as what? 0.15 meter. So let's take our what? Our formula for what? For focal length is not this formula that is for focal length, right? Somewhere else. Focal length equals to radius of curvature over 2, which our focal length equals to what's the radius of curvature? We have it as 0.15 over 2, which will give us 0.075 meter for what? For focal length, right? So now, we find our focal length now, but we need to get what? We want to find the distance of what? Of the object. And we are giving height of the image and what? Height of image and height of object. Let's see first. Height of object rather. So it's given as height of object. So let's go to the other side of the board. So according to what we have in that place, we have height of object over height of what? Image. Sorry. Height of image over height of object equals to distance by the image over distance of what? Of our object. Okay. So now this formula for what? Is for magnification. Okay. So now we're going to be having height of the image is given as 0.12 over height of object is given as what? 0.04. Then equals to distance by the what? Image is unknown. What our object as what? As unknown. So now, if we cross multiply in this place now, we cross multiply this, multiply this. We're going to be having 0.12 v equals 0.04u. Now, according to what we have in this formula here, now we want to equate distance of what? Of the image because we're not asked to find it. So now it means that we're going to ensure that this v becomes what? The subject of what? Subject of the formula. So we're going to equate this one 0.12, 0.12. So therefore, distance of what? Of the image will give us what? Will give us 3 what? 3u. So means that distance of image that turns to what? 3u. Right? Then now recall back to what? To the formula that we have in this place. But this formula now it has all what? All what we are asked to what? To find. Or I'm not sure all what is needed. Now we have 1 over what? 1 over what the distance move of distance of the image is what? Is now 3u now. That is 3 distance of what? Of the object. Then plus 1 over u equals to 1 over what is our focal length? Focal length is what? Is 0.075. 0.075. Now we take the LCM of this 3u and this u. The LCM is 3u. Then multiply 3u all through the what? The equation. So we're going to be having We have 1 over 3u times 3u over 1 plus 1 over u times 3u over 1, then equals to 1 over 0.75 times 3u. So now this 3 u cancel what is here now. U cancel this u is here. So we only have what left. So we are going to be having, we have only one. This one, 3 u here is 1, 3 here is 1. 1 times 1 is 1, 1 times 1 also have 1. So everything is going to become what? Only 1. Then we have plus 3 here. Now equals to, this one will give us 3u over 0.075 rather. 0.075. Why this one will give us 4 equals to 3u over 0.075. Now when you cross multiply in this place now, this multiply this multiply this. So I'll give us 3u equals to, when we multiply this one by this one, let's see what I'm going to be having in our calculator. So I'm going to be having 4 times 0.075. That will give us 0.3. So I'm going to give us 0.3u. 0.3 rather. Now remove this 3 now, over 3 here, cancel out. So I'm going to be having distance of the object equals to, that's what I'm going to be having now. That will give us 0.1 meter. Now, one distance of, now we only have to find the distance of what? Of the object, right? So it means that the distance of the object is going to be what? 0.1 what? 1 meter for the distance of what? Of the object. But if you're not asked to find the distance of what? Of the image. So it means that we come out to what you have in this place. So that image is what? Is tries what? Tries the object, right? So it means that distance of the image now be equals to 3 times, what is our u here? U is what? 0.1. So the distance of the image equals to, that will give us 0.3. So but what you have to find is what is distance of what? Of the object, which is 0.1 meter. Thank you very much. Don't forget to like my video, share, and what, and